we're talking about today is triangle congruency shortcuts. Triangle congruency shortcuts. We're only going to talk about 2 of them today, and one that is definitely not. So what it really means is what we're going to tell is when are 2 triangles congruent based on measurements of sides and angles. So I told you to get out a blue, a red, and a yellow. These are called like ang legs or something like that. So if I say that word, don't be surprised. So go ahead and make your triangle out of that, if you haven't done so already. Oh, thank you. Okay. So everybody's triangles are congruent, right? So then that tells us something. What's the same on all your triangles? Are the reds the same length? And so are all the blues and so are all the yellows, right? So then if 2 triangles have 3 pairs of congruent sides, they are congruent. All right, that assumes that the pairs are between the 2 triangles, right? Does everybody know what I mean by that? Like, there has to be a blue side on one triangle and a blue side on another triangle. There has to be a yellow in both and a red in both. Does that make sense? That's what I mean by pairs. So, we call this shortcut side, side, side. So, SSS. Okay? SSS is the most easily identifiable one for obvious reasons. Right? Because all 3 sides are the same length. It means side, side, side. Okay? Everybody okay with that one? So what I want you to try to do with the angles or with the little sides, I want you to take one of the sides off and try to make a congruent triangle without using the side you took off. So if you take off a yellow, try to make a congruent triangle without using that yellow. So again, if you change one side length, they're no longer congruent. All right, because remember, congruent means that if you lay it on top of itself, it gives you back the exact same figure. Okay? So that's how we want to think about it. All right, let's try another one. Let's use blue and yellow. What? Just. All right, then I want you to use the orange. So blue, yellow, and orange.
I already got it.
Here's what I want you to do. I want you to try, well, first of all, take off the orange and keep blue and yellow in the same angle. Okay? So now what I want you to try to do is with blue and yellow at the same angle that it was when orange was on it, try to fit a different piece of a different length there. No, you can't. It's not possible to try to change this because the angle is, all right? The orange one is the shortest, and everything you try to put on is either bigger, is always bigger, right? Which makes the angle what? Bigger. So, the next one that we're going to talk about is if you have a side and then an angle between them and then the next side, just like we did, we had blue, then an angle, and then yellow, right? What do you have to have there to make it, see, to make it congruent, again, you have to have the orange, right? So side, angle, side works as well. So let's see what that would look like if I have just two triangles randomly drawn. So I would have something like this, then I would have an angle, and then I would have this side as congruent. Over here to this triangle, this would be the short side, the angle, and the long side that's congruent. Does that make sense? So if I name this CAT and this DOG, what is CAT congruent to? No. It's G. See? C goes this way. So it's not congruent to dog, it's congruent to God. No. Okay? So, that is a very, very tricky way. Remember how at the beginning we talked about it has to go in a certain direction? Like it goes clockwise or counterclockwise? This is why I made you do that. Because we see that the triangles have to go in a certain direction. Okay? There is one that doesn't work. And it is angle side side. So side side angle. Okay? So here's what we think about this. Side side angle is a pain in the angle side side. All right. For all our naive people in the class. Okay. So, and that's not a joke. I mean, it kind of is, and it's kind of not. You can't answer if you have ASS. Okay? You don't know if they're congruent or not. So let's look at what that looks like. Let's say I have this angle, and then I know that this is congruent to this. Here's the problem. I can have something that looks like this. Does that make sense? That's why side-side angle does not work. Does that make sense? See, I have the same angle. So let's say I have ADT. Yes, it is. It's a company. And we'll say CIK. See, you would want to say that ADT is congruent to CIK, but it's clearly not, right? Because you'd have angle, then the side, then the side. Or if you think about it counterclockwise, you'd have side, side, then angle. Yeah, I'm telling you, side-side angle doesn't work. So side-side angle does not tell you the triangles are congruent. That is very, very, very important to remember. What does? Which of the two do? So SAS is the first one that we talked about, and what's the other one? SSS. So these two do. Okay? Yeah.
Like, how do you tell the difference between an SSA and an SAS?
That's a good question. How do you tell the difference between a SSA and a SAS? The answer is it has side, then angle, right? Up here it was side, then an angle in between, and then the other side.
So, like, where do you start?
It doesn't matter.
Because either way, you had a side, and angle.
No, you don't. See, it's how it comes. You have a side, then you have an angle, then you have a side. Right? See, here you have angle, then you have side, then you have side, which is two different things. It's all where the angles are. Does everybody see that?
The name of the triangle has to do with, like, the whole thing. You start with, like if you start with the first one on that one, you have to start with the first one on the other.
That's correct. Yes?
So, like, what if you went from, like, DA2? Like, would that be side angle side then?
No. It's side, then angle, but you don't know how long this side is. So you can't mess with it.
Oh.
So you get to this side before you get to this one over here.
Oh, okay.
Okay? So let's look at some that's going to look like your homework, which I'm sure that's all you really care about. So this one's going to look like a bow tie. So go ahead and draw this. P, A, M, and B, O. Okay. So what do we know first of all? Do we know anything just based on the picture? Yes, we do.
You know how many sides it has?
All right. More specific than that. What is congruent? What? All right. At the M point, this angle is congruent to this angle. Why do you know that? What? Because they are vertical angles. Don't need that they're parallel. All right, so our next thing that I'm going to tell you is M is the midpoint of both segments. So knowing that tells me that this is congruent to top or bottom on the right? Bottom on the right. Very good. And then this over here is congruent to top on the right.
No, I'm not kidding.
No, because M is the midpoint of both segments. Right? So it cuts both segments in half. Do you see what I'm saying? All right. So what we're going to talk about from now on is which two triangles are congruent. So APM, triangle APM, is congruent to what? BOM. Remember, it's directional. Has to go in the same direction. No. it goes from A to P, and then across the side with one slash through it. So we go from B to O across the side that we don't know, and from O to M across the side with one slash in it. I agree. It is a little bit difficult.
So is N always the last one?
For these, it was. That doesn't necessarily mean it's always going to be. Okay. I want you to try one on your own. And I'm sorry, I didn't finish this. Why? Why is that true? By which one?
Oh,
SAS.
By SAS. All right, so here, I'm going to have kite. It's going to have a line down through the middle of it. So, kite, oops, it's a little bit sloppy. Kite is a kite. Triangle KIE is congruent to what? Do that one on your own. All right. Shh. Most of you all figured out that this is a shared side, so it is obviously congruent to that. This is a kite, which means that this is congruent to that, and this is congruent to that. So, we want to say that KIE is congruent to triangle TIE by side, side, side. Lastly, this is our last one. What about a picture that looks like this? All right, obviously it's a little bit weird. I'm going to say that this is congruent to this. I know it doesn't look like it. And this is congruent to this. I'm going to call this A, B, C, D, E. So, triangle ABC is congruent to what? All right. So we want to say E, D, C. We want to say EDC, and why would we say that? We would say that these two are vertical angles, right? And we would say by side, side angle. All right, but what did I just get done telling you? So, side, side angle is a pane in the angle side, side, and so I do not have enough information.
how do we know that it's side, side angle again? Okay.
I do not have enough information to tell that the triangles are congruent. How do I know that it is side-side angle? Because when I look at it in any sort of order, you can't just skip around and look at what you want to look at. You have to go in order around the triangle. So if I go in ABC order like it tells me to, because I have triangle ABC, I come across a side that I know, another side that I know, and then an angle that I know to be congruent, right? Same over here. I go around. I have a side I know to be congruent and another side I know to be congruent and an angle, which leaves me to side-side angle. Does that make sense? So you go either clockwise or counterclockwise around the triangle, and you just gather what you know as you go further and further around. So this one, since it is side-side angle, you don't have enough info to tell you that the triangles are congruent. So you don't know that this is true, even though you would like it to be. Okay?